What's going on, you guys? Mr. Allen here. We're about to graph g of x here, a rational function that is already in factored form. How nice. We don't have to factor this thing. But we do got to get some key features here, right? We got asymptotes, holes, intercepts. Anything we see right off the bat? Well, first off, I'm going to cancel these two guys out. That's a hole at -2 comma something. I got to figure out that something. How do I figure out that something? Well, I can substitute -2 back in here and here, which would be -3 over -2 plus 3 is 1, squared is 1. So I have -3 over 1, which would be -3. All right, so substitute that in, get my y value. I already got a point, bro. I already got a point. It's a hole. Awesome. I'm not going to plot it yet. I'm going to wait. All right, how about intercepts? Well, to get intercepts, let's see here. If I plugged in 0 for x, I'd get my y-intercept. So plug in 0 here and 0 here. I'm going to get -1 over 9. So 0 comma -1/9 would be my y-intercept. How about an x-intercept? Well, I want my function to equal 0, right? I want my y value to be 0 to get my x-intercept. Well, how do I get this thing equal to 0? My numerator would have to be 0, while my denominator is anything but 0, because I can't divide by 0. So what would make my numerator 0? X minus 1 equals 0. Add 1, I get x equals 1. So 1 comma 0 would be an x-intercept. All right. How about my asymptotes? Kind of jump right over that one. Well, look at my denominator. What's left? It's x plus 3 equals 0. I get x equals -3. Now, that thing is squared. I wonder if that's going to do anything on my graph. I guess we'll find out. Let's plot some of these things, shall we? So I'm going to scale this out. 1, 2, 3, 4. A lot of times they leave these graphs open-ended for you so that you can scale accordingly. And I'm going to do that right now. Oh, that looks wonderful with the orange. I love it. Woo! All right. Vertical asymptote at x equals -3. Pop that guy in right here. Boom. Hole, -2, -3. That's going to be right down here. All right. What about horizontal asymptotes? I almost forgot. My goodness. Well, my degree in my numerator is larger than my degree in my denominator, yes? So that'd be y equals 0 for my horizontal asymptote. Let's do it. So we've got boom. All right, cool. Wonderful. Now, next up here, we got our intercepts. We have 0, 0 comma -1/9. So that'd be right somewhere in here, right? And let's label that. We're going to have 0 comma -1/9. Since it's not on a number, it can be nice to go ahead and just label the ordered pair, right? And then I've got 1 comma 0. So 1 comma 0. Weird. Weird that it's on my asymptote. Interesting. Well, that can happen with rationals. The horizontal asymptote can be crossed, but it always comes back to it, right? It's like it left home for a little bit to go find itself, but it came back home, you know? The main thing here with horizontal asymptotes is that we're talking about our end behavior, what it's doing on the far ends of my graph. Keep that in mind, right? Vertical asymptotes, no touching, no crossing, all right? Vertical asymptotes, can't do any of that. Horizontal asymptotes, a little more easy going, all right? All right, so now let's see what else. I've got a pretty good picture as to what the heck's going on over here, right? It's coming up like this, and it's going to here. It's going to go through that guy, but then it's going to come back to it, okay? So it goes through it. I kind of missed it there, but pretend I hit it, and then it comes back down to it, all right? Now, my next part here, I got to figure out, is the graph existing here or here? Now, if you're not sure, you can always do a test point, all right? So I'm going to do a test point just to the left of this one here. How about like -3.1? If I plug that in, -3.1 up here is going to be a negative number. Right here, since it's being squared, is going to always be positive. A negative divided by a positive gives me a negative overall, meaning this graph is going to be pointing down right here, right? It's going to be pointing down, which means this thing is going to come up like this and then follow that horizontal asymptote. So really the main concern here is that I just have that behavior around the asymptote taken care of, right? They're both going down right here. And then this guy's going to the left there and approaching that horizontal asymptote. If they asked for any other points in this region, you could plug them in and scale it accordingly. But since it's only asking for asymptotes, holes, and intercepts here, that's all I'm going to give them, and just make sure that the graph is placed in the appropriate region right there. All right. that was pretty Gucci. That was pretty dope. Hope you guys enjoyed it as much as I did. I'll see you guys later.